Okay, let's start. I'll introduce myself. My name is Aya. I'm working as a data analytics engineer. I have been working in the data field for 4 years with Egyptian startups and corporate. And it's a pleasure to meet you today. And I'll let Ammar introduce himself.
Okay. Hi everyone. This is Isam. I'm working as a senior data engineer, and I live at Stockholm, and I have been there on data management field for around 7 years, and I will be glad to share with you some thoughts on data stack today.
And also, thank you everybody for joining us. The topic is a guide to modern data stack. I'll let the presenter take the words, and also you should be able to turn on your cameras now.
Yes, it is. It's working. Okay, I will start sharing screen. Just a second. Mhm. Do you see it now?
Yes.
Okay, great. Okay. Today we will talking to you about what is a data stack is, and in specific, what is a modern data stack should look like, and what's the difference between it and other traditional data stack. So let's start. It doesn't work. Okay. Um, First of all, I would like to talk to you about something interesting. So every year at North America, there is a specific event that happens through the winter, which is a butterfly migration. In specific, we are talking about monarch butterfly, and it take around 4,000 kilometers from North of America to south of Mexico to just uh, live there until the winter is finished. And after that, it get back again. What's really interesting about those butterflies is two things. First one is that it actually have a really significant ability to adapt to the current climate changes. Uh, you know, in those days, we have a lot of climate changes happening, but even through those situations, they still able to adapt and do the migration without any issue. Second thing is the level of generations that they have to complete the migration. For example, if first generation starts the migration from North America and they arrive to Mexico, they might not get back and they die there. And the second generation up to the third generation uh, should continue the journey until they reach to their homeland and continue again, the level of generation continue. So just imagine that a butterfly came into a place out of nowhere and she found it herself in a place to continue a migration process right now. So it's really magnificent that they keep up and they adapt to the changes that they have in their planet. So from there, we should be also to uh, learn this from them and adapt to a change that we have in our technology stack. Um, so, in the data stack, we have a lot of things changing over time. Every day we have a lot of tools and services enabled and solution come into the picture. And of course, the challenge and a lot of opportunity come into place, and we have to deal with. So from there, we will talk about something specific related to in data organization. In one that will deal with the data will have to know what is the best data stack that I should have to accomplish my tasks and reach my goals on business side. So we will talk first about the history of that, or the traditional data stack, how it look like, and what are the challenges that we face there. And that's why we actually thought about the new data stack or modern data stack. And on that level, we will dig deeper into the modern data stack and understand together what are the different levels that exist there, and what also the different tools that you could use to implement each layer. Last but not least, we will talk about the benefits of having this modern data stack. What are the features that you will have in place, any costs that you are going to save, and so on. Lastly, we will give you a little brief about how it looks like now. You know that generative AI is booming right now and it's everywhere, and we're revolutionized by time. But how this will affect the data stack, it still have a really great impact. And we started to see it on the big vendors right now on cloud. And we have now some integration with new services. So you have to know that some changes will happen and kind of in a set of pipelines with specific tools that you should be aware of. All of those setups will make your life easier and enable you to complete your mission with ease. And of course, we will give a technical demo on how we should use one of the modern data stack components, which called DBT. I will take you through this journey on how to use DBT and build some DBT models. Okay, so first of all, what are the traditional data stack? So it's really easy that you could think about what you are currently doing or what you were actually doing before. You have a set of source of data where your data reside, like mobile application, websites, or even CSV file, any place that have your data in, and you would like to get some insights from it. So you simply build a traditional pipeline, which is called ETL. So you extract the data, you put into a data warehouse after you transform it, and finally you will build your own dashboard or reports from that data. So you have again some set of structured databases or files, and you build your own ETL pipeline by transforming or cleansing the data. And finally, you use your own dashboards to visualize it. So the question now is, if it looks good, what is the problem here? What are the challenges that we face using this traditional stack? I will raise this with a question to you. So let's imagine now that you would like to build a data product. By data product, we mean, let's say, a dashboard. Let's say about you have a website and you would like to understand how the customer behave in your website, and you would like to get a number of visits, how many minutes they spend on your website, how many pages that they open through their visits. So you are looking for a set of KPIs, and you would like to build a dashboard for those KPIs. So let's imagine that you would like to build this dashboard, and you have your data inside one of your source systems. So before answering this question, you have to think about three things. What will be the infrastructure that you are going to use? Let's say that you have on-premise data warehouse, and you would like to bring your data from source system and put it into the data warehouse, the one that has been set up on-prem. And also you will have to think about the software that will do the cleansing and transformation for you. Of course, this will have a specific license that will be tied to the vendor. And lastly, which is of course the data itself, how the data will look like. How is it stored in one system or different systems? Is it structured or unstructured? So imagine those kind of consideration, and let's say I would like from you that to give us let's say any numbers that you could imagine to build such a use case in your organization with the traditional stack that we just mentioned. You are going to build an ETL, so you have to think now about what are the transformation logics that you are going to do, and also how you are going to push the data, the transformed data on your data warehouse. But also before answering this, you need to think about you might face some such challenges, like you came to the data team on data warehouse and ask them for such application or such a dashboard, but they get back to you and say, we don't have a place for you. We don't have enough quota or resources to let you run your dashboard or bring your data in. So at that time, you will ask them to add more resources and get appliances or machines to increase the capacity of the warehouse. So on-prem, and you have to ask the vendor for that, which will, of course, will bring that with an additional cost, and it will take time. It might reach to even a month to just increase the capacity of the data warehouse. Also, when it comes to the software itself that will do the transformation for you, this one has also a capacity and the resources that you have to think about, and also to have a license. And this license might include that it have a limited number of users. And if we'd like to increase the users that are going to use this platform, we have to pay more. And finally, last but not least, the processing itself. What type of processing that you could do? Using those traditional stacks, you are limited to the traditional batch processing that you could do on batches of data every day or each night. But you have any idea about the real time. You don't have the infrastructures that could support you in such scenarios. Finally, what if the data that you should use already scattered and you have to combine them, and you don't have the tools that enable this for you? So all of those aspects you should put into your mind when you think about building a new product or building a new use case, and the data is not in place, and you have to bring it from source, moving through all of those phases that we talked about, through the source, the ETL, and finally the data warehouse. So if you could write your answer in the chat, or what do you expect for this to take? A month, a day, or even a week? Please give us a view on that. Can anyone guess any number or give his view on that? How many days you would expect for this product to be finished if we take the customer scenario that we talked about, you have a customer on your own website, and you would like to understand how they behave. So you would like to understand how many times they log in, or how many hours they spend, or even from which locations they visit your website. So to get those KPIs, you will have to build this pipeline. How many long should it take from you to build this?
The attendees should be able to send the chat, so I changed the settings so you can answer the question.
Okay. Okay, so using these traditional stacks, especially the one on-premise system tools, it might take up to a month or even more than that, because to enhance or increase the infrastructure in your on-premise system, you will have to go back and forth with different team and the vendor of course, with cost estimation to increase or enhance the capacity to let you build a new use case. And also the data is scattered, and you have to ask many teams, and you have no idea about either if this data is available or not. You still don't have such catalog to give you overview about what data that the organization currently have. And last thing is the capacity that you should have in your transformation layer. If you are running your transformation layer on a specific machine, and you find that it need to run for around an hour, at that time you will have to wait for an hour until the report is finished. But what if you would like it to be finished in 1 minute or even less than that? You'll have to increase your capacity. And again, when it comes to capacity and the resources, you will have to ask for resources, and which will take more time. And the solution for such capacity resources and scalability issues will find a solution for it on our new data stack. And also the flexibility to use different tools or different mechanisms to load the data, and the ability to discover the data even before we start our project will have such solutions and capabilities in our new data stack. So this is just give us a glimpse of what are the challenges that we have on our current traditional data stack that still companies use it for some use cases. So what is modern data stack is? It's not like the pictures that we have here. It's not something scattered or a lot of services that are connected together. The data pipelines inside the data stack or the modern data stack connected together, but in a more structured and unified form. We will visit together now the different layers that we should have in our modern data stack, and on each layer we will mention what are the tools that we could use to implement such layer. So first, before we talk about the layers, we need to make sure that the final pipeline, the final stack that we are going to use on the modern data stack should enable us to flexibly change any tool or use new tools easily. And of course, it should be scalable. There is no any scalability issue anymore. Of course, it would be really good if we could use that modern data stack with a cost-efficient way and less than the cost that we have on our on-premise system. And finally, of course, the one that drive all of that is the business. The business should get its insights faster. So when we would like to build new things or discover new data, we should come into place and discover it and say how it will look like to build such thing, and we build it in a way or two. So it shouldn't take more than, let's say, days, or even might reach to a week, depending on the complexity of your pipeline. So you have here many different layers. It looks so big, but we listed here a lot of tools just to give you the option to choose and give you overview about the different tools that we have currently in the market on which layer. So we'll start from the source and talk about it. So simply the source is where your data resides. So it might be a website, an app, or a platform like SAP or custom CRM for managing your customers, or any platform that you have your data in. So this data, you want to leverage it and get some insight from it. So you want to get into the final BI reports. To do that, you have to first load your data, combine them, clean them, and feed into the data warehouse. To do that, you have to move to the next layer, which is ingestion. You still are going to extract and load the data, but the transformation will come next. So you are now going to use ELT, not ETL. So you will extract it and load it into the storage system. And by the storage system, we mean it might be data warehouse, or it might be a file system. So if it's a structured data, you will feed into a BigQuery table or Snowflake, or even Databricks or Amazon Redshift. But if it's unstructured data, you could feed it into a file system like Google Storage Bucket, or Hadoop file system, or S3. The idea here is that you shouldn't have to filter anything or drop any data while it's ingestion. You're just going to bring all of it and combine all of them inside one single place. It's it might look like the data lakes that we could talk about. So you will have a single place for everything that will include your data, the structured and unstructured data. So you have here for ingestion, you have many tools like Spark. If you would like to work on a heavy load data and do some cleansing onto the place, or even if you have streamline applications, you could still use Spark structured streaming. And you could also use tools like Fivetran, which have ready in place plugins which connect you with just a set of configuration to the source system. So the idea here for those new tools is that you will find everything is ready and configured for you. You're just going to connect it as connecting the dots. It's a matter of easy configuration to set up easily with fast. Now, everything is...
Before moving to a new point, I want to ask if you worked before with those tools, can you please raise your hand or share your experience if you are familiar with any of the tools?
Yes, this would be really great to have.
Is it new for you all?
I think the admin just mentioned that they might not have the
Yes,
control.
you can just raise your hand.
I hope they can do that.
Everyone should be able to raise their hands, and everybody should be able to chat now as well. So
Yes.
Cool. That's great. Yeah, just please, if you familiar any tools here. Let's
For
take,
example, Airflow, DBT, Stitch, Python. I think it's really new.
we have some numbers here. This,
Yes. Good. Databricks. Yes.
that's really cool. Yeah, Python, no one forget Python. Python is everywhere.
Yes. I think Airflow and DBT is still new because
And even the tools like Vectran or Airbyte, those are commercial tools and not might be used by everyone. The one that is really popular is Spark. If any of the audience is a data engineer, he should use it. And also the cloud tools here like BigQuery or Snowflake, it depends on if your organization work on cloud, of course he should use one of those. Or I mean, for Amazon or for Google provider, or even the Databricks, or even for Azure, they have also their own data warehouse system.
okay.
I I think I
Okay.
think yeah. Let's continue from there. So we end up now that everything now reached to the data warehouse for structured data, and unstructured data still will move it to the file system. But we end up with a single place where we have everything. So that will enable us later on to have a view or a global view on the data that we have. So imagine that you would like to build a dashboard on Tableau or Power BI, and before doing that, you would like to ask about the data. What's the data that you have? Do you have, for example, a customer satisfaction index? You would like to search for this KPI. So through a single place that will have everything for you, you will be easily to do that with ease. Um, Through cataloging. The catalog is a tool on any of those BigQuery or Snowflake or Amazon Redshift. All of those tools have a catalog where show you all the metrics and data sets that you have inside your organization. So when anyone get any new data and put it into a table, he will mention what are the data is and do some description for those such fields. And even if they create some extra transformation for it, they will list some description for those data. And all of those descriptions and metadata related to the data itself will be provided for you through the catalog. So you should have the flexibility to search and discover the data easily. Okay, so the data is moved now to the warehouse, and you would like to build a dashboard for it. You could, of course, use any BI tools, or even if you'd like to build machine learning tools, like Google AI or AutoML to build your own dashboard, even Python, sklearn, or such as models that we have right now. You could use any of these tools to catch the data that you would like to and build this your own report or machine learning model. The thing is, we cannot move directly now to the BI because the data still need one extra step, which is observability, which means we cannot get trusted to the data until we make sure it's qualified. We need to make sure that data quality rules is already applied and everything is good. You could think about data quality checks like customer ID cannot be null. For example, you cannot show a report and you have, let's say, 1,000 customer who show a specific behavior and you have null for their IDs. So you cannot choose that. You cannot have null values for a price or something. So anything like null checks or even business checks, let's say that you cannot expect negative values for let's say a price or salary for employee or something. So you need to make sure that the data is already qualified before building your own report. And you do that by moving through the observability checks, where you have your own data quality platform, where you build your own checks and apply it on the data where you have in data warehouse and file system. And now, yeah, you are free now to build your own reports because data is trusted and qualified. Last but not least is the orchestration part. Imagine that you want to build now the ELT, and you have also a reports that you would like to get the data and show it. And you have too many dependencies in your pipeline. To have such a pipeline in single place with just connecting the dots, like when the addition is happen, I will do the transformation, and when the transformation is finished, I will trigger the Looker dashboard or Power BI dashboard to show the new data. To connect such operations, you could do it easily through the orchestration part. So it enables you to connect the dots and complex data pipelines with ease. Tools like Airflow or Exter already in place and have all the connections or plugins that enable you to connect and configure any tools. Like you could from Airflow connect to Spark and wait when Spark operation is finished, and after that you could trigger Power BI or Looker dashboard. So you have the flexibility to have a lineage or a full lineage for your own data pipeline. Whatever it's complex, you manage it in single place. Finally, still, the people who would like to take an action from the data or the insights need to have those actions inside the original system, which is the source system. For example, let's say that you have your own CRM system or Google Ads system, and you would like to offer high-value customer a specific ad. So you still don't know what are those high-value customer, where you got this info from. You will get it from, let's say, a machine learning model, which write those high-value customer in a specific table in data warehouse. So you will have to get the data from data warehouse and feed it into the Google Ads system to fetch those high-value customer and send them the appropriate ads. So this we call it as a reverse ETL, or we feed the output of analytics into the action systems, where we take the actual actions and we get benefits from the analytics that we already made on data side. So as you already have seen, we have a lot of tools and a lot of things that we could use from, but still we need to choose a tool to use at the end. So which tool we should use, for example, through the ingestion, or which data warehouse should we use, or which tool we should use for streaming or batch or through the orchestration. There is no a clear answer for this. It's still a hard question to get an answer for it. But through this slide, we will give you guidelines to follow to get into your final result. So when you ask this question to anyone, it will always say it always depends. It's really depend, because if you are going to do batch, it will be different when you do stream. If you have frequent data or high volume data or unstructured data, every tool have extra benefits or extra feature to deal with a specific use case. There's no tool for everything. We're still able to distinguish between the tool and say that this is a data warehouse, this is an ETL, this is a reporting. But inside each one of these pillars, we have a lot of tools to choose from. For example, we will mention here a popular example like Apache Flink and Apache Spark. We would like to distinguish between of them and see which one we could use in which scenario. This is just an example, and you could do that with any tools that you find yourself conflict with. So to do a comparison or to tell you which platforms that you could use, we will have two pillars to think about. First one is the technical consideration, and second one is non-technical consideration. For example, what would be the data volume or velocity? If it's a really big batch, Spark will have more robust pipeline to deal with. If it's a really high stream, Flink will be more flexible, because if you would like to get more details, you will have to look into the features. For example, in Flink, you have the flexibility to process the message at least once. But on Spark, you might have process the same message multiple times in failure time. So you have the control inside Flink, which give you more flexibility than Spark. Still, both of them will process the stream data with ease, but the Flink will give you more control. That's why we might use it if you have really high velocity data, real stream data. If we talk about how Spark deal with large volume of data and how it perform, you will find that Spark is dealing better with high volume data through distributing the work through the workers. This is come by experiment and feedback. Both of them have a community, and we will talk about this later. But again, you still have to think about what are the languages that I'm going to use. Do you would like to have more flexibility? Okay, you could use Spark. It provide R, Python, Java, and Scala. For Flink, you still have not the same flexibility. We have Python, I think, and Java, but you don't have R and Scala. How about the error handling and recovery? Spark, when an issue happen, it stores the state of the stream, and it could get back and reprocess the stream again. Flink also does the same, but as I mentioned before, Flink will make sure that this message is only processed once. But Spark, when it comes to from the failure, might process the same message multiple times. So again, all of those such aspects is you could consider it as an initial steps that you could think about, like the volumes, which one provide and support which language, how both of them deal with error handling and recovery. But finally, based on your use case, if it's a really complex one, it will be really better to do a POC for both of them. You will run the job here and run the job here, and you will see which one of them run better and give you the flexibility to add more features. This is for the technical considerations. For non-technical considerations, of course, the community is really matter. Um, when the community is big, when we have issues or bugs, and you have a pool of developers who really enhance or give quick fixes to those bugs, this really help and get you upgraded uh, with ease and into the moment. Um, of course, the stability, both of them still give you a stable platform. You have a cluster and everything is managed, but which one of them is give you more feature? Like if we talk about um, integration with different system, for example, on Flink, you might have a ready package to connect with, let's say, HBase or Kafka. On Spark, you will have the same, but you will not find much more flexibility to connect with HBase, for example, because if any one of you ask about this, you will find that the package has a lot of issues and doesn't provide much flexibility. But on Flink, it's really moving good and it's mature. So this is one of aspects to talk about the maturity. How the platform that you are going to use is mature enough to connect with different systems and enable you with flexibility to configure the system and pull of the data from it. For example, on Spark, when it connects to Kafka, you have to make sure that each instance or each worker on Spark will connect to a specific partition on Kafka. So if you have, let's say, 5 workers and you have only 4 batches, or sorry, 4 partitions on Kafka, you will get one free instance that will do anything. It will be enabled every time, but it will not do anything. So it's not flexible enough, or it's not, I would say, optimized when it comes to integration. And it depends. You would see which one of them give you those such optimization mechanism in place. You could use that if Flink provided, instead of using Spark, which doesn't optimize the pipeline efficiently. Yes.
But I think the good news is if they already familiar with the foundation like SQL and Python, you can easily work with the new tools like dbt and Airflow.
Yeah.
So don't worry about, we have a lot of tools. If you are familiar with the foundation, you can work easily with them.
Yeah, that's a really good one, because if you don't know anything about any of these tools, you still don't have such a limitation to choose one of them. You still have other tools to choose based on your experience. As I mentioned, if you have a SQL flexibility and a clear understanding, you could use dbt, for example. It provides you the same idea, and you don't have to learn those such complex big data platforms. So moving to benefits of data stack. Okay, when we use the modern data stack, we move to the cloud. So everything now is on the cloud. And when you are in the cloud, you don't have to worry about the infrastructure. It's just ready for you. Just click and the service is enabled. BigQuery, if we talk about GCP, for example, BigQuery is ready. You could just create the table and ingest data. You don't have to install and configure. You don't have to worry about the infrastructure and the capacity. When you would like to pull online stream data, you have the service that could receive into seconds of data without also worrying about the cluster size or number of machines. You got just enable the dynamic allocation, and it will automatically increase the number of instances of number of machines that we use inside the job. So you don't have to configure everything by yourself. Everything is already enabled and easy to scale on cloud, which will enable you to build real-time analytics. You will now have the flexibility to not only look into batches, uh, which you will run every day. It's still acceptable and you will use it. But also, if you would like to run an ad hoc complex analytics right now and you are looking forward to show the output right now, you don't have to wait up to tomorrow to show the output. Of course, the cost will be more efficient because you don't have long-running instances all the time. You pay as you go, or you pay based on your usage. Let's say if you would like to run a script right now and you already finished, an instance will be up when you would like to run, and once you are done, the instance will be removed. So it's like an instance come into place and machines come into place. You will be charged when you run the script, and once it's finished, it will be removed, and you will no longer have any cost or additional cost. Of course, data quality tools now is easy to use. Imagine that everything is one place now, and you are now have the control because you manage everything in one place, whatever is structured or unstructured. And also the tools is ready for you when you would like, let's say you have a lot of data on BigQuery as an example. When you publish the tables, you will have tools like Databricks or data catalog, which will be already run in the background. You don't have to do anything. You could just go to the catalog and show the data or search for your data assets and see which of those metrics is really qualified and have a green validation. You could do an extra checks once you lose the data or before you lose the data. Again, all of this is managed by scalability. You are in the cloud. There is no limitation. Like the butterfly, you are flexible. You adapt to the change. Whatever your business is becoming bigger and you would like to get more resources or use more services or upgrade to a specific version of software, this is come packaged onto the cloud without any consideration about all the time that it will take. It will be just with one click. If let's say if Google upgraded BigQuery to a specific version, or they created a new service like Cloud Run over Cloud Function, you will find it already there. You don't have to worry about anything about downtimes or anything. You will be on the top with latest changes on the market. When I talk about GCP, this is just an example. You will have the same experience on any different vendors like Amazon or Databricks or even Azure. Democratization of the data. As I mentioned already, when we have the data in one place, anyone could now just request to access the data and fetch it and use it. On the old system, to reach the data, you have a lot of challenges because first of all, you don't have even the access to show the metadata. But here through the catalog, you have the option to see what are the data is there, what it really represent. And after that, when you would like to really get the data itself and build something out of it, you'll just ask for request and you get approval. So data sharing has become easier. which will enable faster analytics for everyone in the organization. So we come to the last thing, which is, okay, let's say we are now convinced with the model data stack and we would like to build it right now. Or what about if we already have the same setup right now and we would like to keep up with the change that we have right now? If you already, I think everyone already now know what's happening on the AI side. We have now generative AI, which will impact the data stack that you are going to use. So we would like to know how the generative AI will affect the data stacks that we just talked about. Is it going to add an extra layers? Does it will make it more complex or less simple? Or should we provide a totally new pipeline or new data stack? How the generative AI will change the match here? So simply, the generative AI will enhance our experience and make our life easier. And we could see that on different aspects. If you go to, let's say, your data stack, let's say you would like to enhance your ETL or you would like to enhance your ALT. So you would like to build a DBT model or a PySpark code, any code you would like to build right now, you could simply go and ask ChatGPT or any generative AI tool, Gemini or Llama, and it will get back to you with a correct or accurate answer. So you do it, but you do it faster now. And also, the good thing is that the tools that we use in our data stack right now will enable those such features inside the tool itself. You don't have to go up and forth with those chatbots. You could just use such capabilities inside the tool itself. Inside the DBT, for example, you generate a documentation for your own models. So you could now just with one command, you could automatically generate sophisticated documentation, which will do a documentation for your own code, for the models, for extra logic that you build. You don't have to explain it. It will get it from the code. It will understand the code and give a brief description about what this model does, what's the logic behind it, and what's the output of it. So it will be really more enhanced and moving faster. Next, let's think about the data quality. We mentioned that we cannot trust the data without it has been verified and qualified. Now, if we think about how we should do that on AI, AI will help us to uh, do the manual jobs for us. We don't have to, let's say, go and fill the missing values. It will just, with one check, we will ask it to fill those values to fulfill our requirement to build, let's say, a machine learning model or build a dashboard. So it will come into the data and will understand it and put the correct value or the appropriate value to miss the value for the missed value. So if any one of you build a machine learning model, you will see that to handle the missing values, there is such use cases that you could do, like you take, let's say, averaging, or if you'd like to standardize it, there is such different ways to fill the missing values or null values. But the AI will do it for ourselves. We don't have to think about it. It will do it easily for us. The tools that has been mentioned here is a tool that is going to enable this and improve such capability, but it's not limited to these tools. This tool is just an example. but a lot of tools or platforms coming into the place and enable AI into their architecture. Also on the analytics world, when the analyst or the business user going to write a query right now and ask for some data, he don't have to do that right now. He could go and just type it with a human language as a text and ask for anything. So the generative AI will take this text and transform it to the appropriate query and connect to the correct data sets and brings the data and calculate the value that he is looking for. Let's say he would like to get the average time has been spent on the website for a specific day. We will just ask this as a plain text and everything will be managed by the generative AI. By the way, uh, tools like ThoughtSpot is already doing that, but it's not doing that like the generative AI does. It still will enhance it and becoming faster and accurate and intelligent when it uses the current generative AI, NLP models. Yeah, when we come to the area like AutoML, or you would like to build a machine learning model, don't have to be expert right now. Any business user could go and say, I would like to build a machine learning model to do a specific thing and get a specific output and refer to the data set, and it will be managed and created automatically. All of those such scenarios already in development right now. Tools like AutoML inside Google already do part of this job. Inside AutoML, you just use an already ready models for you, and you don't have to worry about the optimization or parameter tuning. All of this is managed for you. You have just to use it and feed it into the data, and you will get an output. Last but not least, the personalized user experience. Imagine that you would like to, you are in sales department and another developer or analyst on marketing. Each one of you should view the correct data assets related to his department. If you go into the catalog and you would like to ask some questions about sales, you will get the sales data related to your department. For the marketing analyst, he should see the most appropriate assets or data assets which match his domain. This is just an example, but you could think of it as a personalized experience per each profile inside the organization. Also, on governance side, we would like to make sure that everyone is following the rules and the data is qualified and shared on the correct manner. So those such of validations or rules will be applied by the AI. Last thing is the scalability. We see that we already in the cloud and you don't have to worry about it. But the new thing about the AI that's going to add is the optimization for the current resources that you have. It says that you have a cluster and you write a query to get data from a database that on this cluster. Don't have to worry about the query is optimized or not. Just write the query and it will be enhanced and optimized for you. The data itself, when it's stored inside the platform, it will be stored with an enhanced and optimized way. Every platform that we could use later on the data stack will have the generative AI in place that enable its function with more optimized and efficient way. Yes, that's it for me. I think it's time now to demo. I think back to you, Aya.
Okay, before starting the demo, do you have any question? You can write it in the chat or the Q&A section.
Just wait for a couple of minutes. Just take time to. Yeah, I think we could start. And if anyone has any question, you could leave it in the chat. We will answer it at the end.
Okay. Can you see my screen?
Yeah, I think it's visible.
Okay, our demo will be about DBT, but before starting to work with DBT, I'll define what is DBT. DBT is a platform for data transformation. It's enable you to write SQL queries and build data models. But to start working with DBT, you need to have your raw data on one of the cloud data platform like Google BigQuery or Snowflake or AWS. And for this demo, we will use BigQuery. BigQuery Sandbox is a free version of BigQuery. You just need to Google GCP and enable BigQuery Sandbox. It's free. You just need to register by your Gmail account and build your project and start writing some queries. Okay. Can you see the new tab?
Yeah.
Yes. Okay. I'll show you the raw data. We have a schema called DBT demo. It's a basic data. For example, we have a data about customers. Customer ID, first name, last name, and customer name, combination between the first and last name, and customer orders. Okay, we have order ID, customer ID, order date, and order status. And the last one for the payment. Okay. We have data about payment ID, order ID, payment method, and payment amount and date. You can replace this data with any data set from the internet, or you can use BigQuery public data set. And you can upload CSV files or Excel file to build your data warehouse or data model. All is good? Okay. Now I'll show you how to build DBT models. Okay. We have two versions of DBT. We have DBT Core. It's a command line tool. You can install it on your Windows machine or your laptop. And we have a version on cloud. It's a free version. You can build your own project and test your data. It's a free of charge. You need to register by your email and build your own project. And from the development, you have the cloud environment. It's an easy tool. It's not hard. You can just follow the documentation, how to build the project and configure your data warehouse, GCP or Snowflake or AWS Redshift. Okay. The important part here, you need to define your data source. Like we saw on BigQuery, we have raw data about customer, raw data about order, and raw data about payment, and give it the data set a name. This is to define your data sources and raw data. And then you can start the transformation. Here, for example, I just took the raw data and doing concatenation between the first name and last name. It's a basic SQL query. And you can query from dbt itself to just see the data, and if you need to add something or remove something. For example, we can change the space and we can put another thing. And you can now build the model on your, sorry, you need to save it. And here, dbt will build the model on GCP. So when you check your BigQuery and check row customers, okay, we replace the space with another special character. So the basic function of dbt, you get your raw data and doing some data transformation on it and build the model on your platform or GCP or Snowflake or Amazon Redshift. And the new feature of dbt is to see the lineage of your model. Here we have the raw data or the source data customer, and we did some transformation on it. We built raw customers, and the final table that we will build now will be the fact order, so you can track the changes of your model from the source to the destination. The same for row orders. We can do some data transformation or data cleaning or renaming the table or the columns. Sorry. From here, you can query like the data warehouse, so you can see the data, and you can see the SQL query. It's a special keyword on dbt source mean. This table is a raw data. It's not a new model. It's just raw data. So you can replace the source. You can replace the full name of your table with just the source. And here you can see the full schema, the data warehouse schema, and the table name, and the data set of BigQuery. If you need to take the same query and run it on GCP. And from here, you can build the model on the data warehouse. And the last thing, to build the fact table. Our fact table will be a combination of the customer raw data and the order raw data and payment raw data, just to see how the customer pay for the order and first order and the last order. It's a join between the customer and customer orders. Here is the result of the query. For example, we have some nulls value. We can replace it from here. For example. It's a typo. Okay, we can skip it now. And you now can build the model on BigQuery. If we switch to BigQuery, we will see it. Okay, now we have the fact table, a combination between the customer data and the order transaction. And the main feature of dbt is the lineage. So we have now the final model, which is the fact orders. It's a combination between the raw customer and raw order. which is coming from the data source customers and the data source order, so that you can track the changes of the table if you need to change something in the data source, if you need to change something in the staging layer, which is the raw customer or raw order, and the final table is the fact. So you can track everything, and every change with the data, you can see it from the version control. You can revert the change or just to commit or add more steps. The main required or the main skill you need to work with DBT is SQL. So it's direct SQL with some keyword like source or model, just to change the full name of the table with a shorter name. For example, here is instead of writing the full schema of the table, you can just refer it with the reference keyword, or if it's source data, like we saw on the raw data, you just need to refer it with the source name and the final table name. Let me know if you need to know anything else, or just raise your hand or add your question in the comment.